Hello students, today we are going to start third chapter of class 11, that is trigonometry. In this video, I will be introducing you to a new unit in the measurement of angles. Till class 10th, you have learned about that. In junior classes also you have learned that we measure angles in degrees, right? You know that the complete angle around a point is, this is complete angle. Complete angle in a point is 360 degrees, right? Now here we are going to start a new measurement for new unit to measure angles. Earlier we had learned degrees. There is another unit which is called radians, right? Radians. So you must have learned that whenever we have two or more units for the same physical quantity, then they must be having some relationship between them. Like if we want to convert inches into meter or meter into inches, we can have a relationship to convert one into the other and so on. Similarly, degrees, like we know that in a circle, if we have a circle, circle's complete angle is 360 degrees. So what is now the definition of another unit which is radians, right? When the length of an arc inscribed on a circle is equal to the radius of the circle, then the angle inscribed by the arc is 1 radian, right? Now this is the definition of 1 radian. How do we define 1 radian, right? So when the length of an arc, circle, like this is the circle, right? Now let's say this is a point A here and this is a point B here. Now you can call this arc AB. This AB is an arc on the circle. So when we join two radii to different points, the part of the circle which is inscribed in between those 2 points, this is called R. Now the definition says when the length of an arc inscribed on a circle is equal to the radius of the circle. That means the length of arc AB is equal to the radius. This is the radius. OA is the radius. When this OA length is equal to this OB length, in that case, the angle inscribed here will be 1 radian, right? This is 1 radian. So this is the ideal definition of measurement of 1 radian. Now, what is the relationship between these two different measurements of angles? How do we relate them? See, by this definition only, I'm coming to find the relationship between this and this. When the length of an arc is described by a circle, that means if we are talking about the whole circle, right? Angle in radians. See, this is angle in radians. Now you can write that since we have a relationship between the length of the arc, which is L, and this is the radius, and angle is written in theta. So when this is equal to this, in that case, the radian is 1 radian, right? So what if length of arc is twice of radius? Then the angle in radians, theta in radians, is equal to length of arc upon radius. Like if I asked you, what happens if the length of arc is twice? Twice, so 2r, what is L now? L is twice the radius. So 2r upon r becomes 2. In that case, the angle becomes 2 radians. So we can find this measurement by angle in radians is equal to length of arc divided by radius, right? So theta in radians is L by r, right? So this is how we find the angle in radians when length of arc is given and radius of the circle is given, right? Now let us derive the relationship between these two things. Okay. Now in this case, let's say this is the radius OA, right? Now what happens when we take the length of arc as a whole circle? See, theta in radians is L by R. We have just learned, right? What happens if we consider the length of the arc as a whole circle? The whole circle is what? Length of arc is the circumference of this circle, right? What is that? It is 2 pi r. In case of complete angle, that means the length of arc is equal to the circumference of the circle. So this is 2 pi r divided by r. So theta in radians is equal to 2 pi. Right? Now what we have derived? That means we had just learned that the complete angle of a circle is 360 in degrees. When we measure the angle in degrees, it is 360. And when we are finding the angle with respect to radians, this whole complete angle comes out to be 2 pi. That means the measurement of 360 degrees is equal to 2 pi radians. Right? Now this is the relationship that we have come out so far. Right? This is a relationship. Now what happens if we have to convert degrees to radians? Now 360 degrees is 2 pi radians. So 1 degree, when we have to convert it in radians, it is 2 pi by 360 radians. So 1 degree is pi by 180 radians. Right? So this way, if we have angle in degrees, we can multiply that angle by pi by 180. So we will get our answer in radians. Right? The other part is like 2 pi radians is equal to 360 degrees. Right? So if we keep 1 radian here, this becomes 360 by 2 pi degrees. So 1 radian is equal to 180 by pi degrees. Right? So this is the relationship when we have to convert degrees into radians or radius into degrees. We can use these two formulas. Otherwise, you very well know the relationship between these two. You can use it anytime. Now, here you have to remember few things. First of all, when we convert angle into radians, the angle contains the term pi. Right? Let me show you one example. Like 360 is 2 pi radians. So when we have to write 360, it is 2 pi radians. When it is 180 degrees, it will be what? 180 degrees is pi by 180 in, see, 1 degree is pi by 180 radians. So pi by 180 into 180. This is, so 180 is equal to pi radians. So angle, when we have to write angles in radians, the pi constant will be there, right? Let's say we do one more thing. What is 45 degrees? 45 degrees is pi by 180. This is the degree of 1 degree into 45. That means 45 degrees is equal to pi by 4 radians. Now you should learn these values by heart. Pi by 4, pi by 2, 2 pi by 3. You should Remember these values so that you don't have to calculate whenever you're doing these questions, right? Another thing we need to learn is when we are talking about angles in degrees, sometimes that angle is not exactly a complete degree measurement. It has some subparts also. Like when we talk about time, we don't get time always in hours. Sometimes we have to go deeper into minutes and then finally into seconds also, right? Like hours, then we go into minutes, and then we go into seconds. We never write those measurements, time measurements in decimals, right? If we have 135 by 2, we will not be writing it into decimals. What we will do, we will divide this by this, the complete number will be hours. Then we multiply by 60 to get minutes. Then we multiply by 60 to get seconds, right? Same way, 1 degree is equal to 60 minutes, right? And 1 minute is further equal to 60 seconds. So you have to keep these things in mind, right? Whenever we are going to get answer of radians in degrees, we will not leave it in fractions. We will not put it in decimals. We will solve it up to degrees, minutes, degrees, then minutes, and finally in seconds, right? Let me do one question here, which goes deeper into this, right? Like 1 by 4 radian, like 1 by 4 radian. So how can we convert radian into degrees? See here, radian into degrees, we have to multiply by 180 by pi. That means 1 by 4 into 180 by pi. And this is now converted into degrees. Always put proper sign so that you are aware what you are doing. One more thing, I told you earlier, if you have got pi in this, like in this conversion, 180 was pi radians, 45 degrees was pi by 4 radians. So I did not use pi as 22 by 7 here because I told you the angles are expressed in the form of pi, right? But here, when we get angles in degrees, we have to answer it in proper numbers. Pi has to be removed. So in this case, 1 by 4, this is 22 and 7 goes into the numerator, right? So now we have ultimately converted this whole thing into a fraction. Now simplify this, what do we get? 4, this is 45, right? And now we have 45 into 7, 5, 3, 315, 315 by 22 degrees, right? Now, this is the degree measurement, but I told you we cannot write this in a fraction form or neither in decimal form. So what do we do now? We divide 315 by 22. 22 1 times 22. 9. 22 times 4 is 88. Right? So now we see this is the complete degree measurement, which is free of any radicals, right? So what you can do is this is 14 degrees, and what is left now? 7 by 22. 7 by 22 is the part of the degree which cannot be converted into 1 degree. It is less than 1 degree. That means when something is less than 1 degree, we go to the next smaller unit, which is minutes. So we convert it into minutes by multiplying this into 60, right? We are multiplying this by 60 to convert it into minutes because we cannot make this degrees. This is a fraction. This is a value which is less than 1. Now multiply this by 60. This will come out in minutes. 2 11s are 2 30s are. So that means I'm doing it here. 14 degrees, 210 by 11 minutes, right? So now again we have got another fraction. This is not a complete number, whole number. So 210 divided by 11. 11 ones are 11. 11 nines are 99. 1. That means this 19 is the complete minutes. But this is a fraction, 1 by 11, which cannot be converted into minutes. So this is 14 degrees. Now we write it as 19 whole 1 by 11 minutes. So we get into 14 degrees, 19 minutes. Now this 1 by 11 is a fraction which cannot be converted into minutes. We further go into a smaller unit, which is seconds. So I convert 1 by 11 multiplied by 60 into seconds, right? Now, even if we get a fraction over here, we cannot go further because there is no smaller unit we can get into. So we have to round it off and write it small, nearest possible value. 11 times 5 is 55, right? So what we can do is 14 degrees, 19 minutes and 5 seconds is the best possible value we can solve up to, right? So the value of 1 by 4 radians in degrees is this much. 14 degrees, 19 minutes and 5 seconds, right? So this was a basic example to convert radians to degrees, and we have done two in from degrees to radians also. I hope you have learned this much. And if you like this video, please do contact me through my profile on Urban Pro. Thank you so much for watching this.